say a little bit about your organization and why you are willing to field all our questions today?
Some of you may know that our organization, the Laboratory Safety Institute, is a nonprofit for safety in science and science education. For the last 45 years, we have educated over 100,000 scientists and science educators in 30 countries and 150 different kinds of labs. Our laboratory safety guidelines have been updated. We now have the extra crispy version, and it's available online on our website, labsafety.org, with 40 suggestions for a safer lab. Very graphic, thanks to Connor Michael, our webmaster. And I would encourage all of you that are interested in lab safety to get yourself a free copy and then ask, how am I doing on all 40 of these things? Share it with a colleague. It's available in 23 languages, including Braille. So, Sue, I guess that's the introduction.
That's cool. I'm impressed that it's available in Braille. That's the first time I've heard that. And I'm just imagining what it would be like to be a blind teacher in a school, perhaps for the blind, keeping lab people safe. I'm sure it's doable, but it certainly has its challenges. So this is an open roundtable, folks, on what questions you have. And I'm going to start it off, Jim. If I want to find the newest, what I can have and what I can't have in my lab, it's not easy to do through my state organization. Is there another way to get that information?
Yes. And I should begin by saying, I don't like governments telling us what we can and can't have. Okay? So I would like to suggest a process for you that begins with going to Staples or somewhere and getting some Avery or Denison colored dots. And then put them in the stockroom and put them in the labs. And every time somebody uses something over the next year, put a dot on it. And at the end of the year, you're going to have everything that got used. Make up a list of everything that didn't get used and circulate it among your colleagues and say, is there anything here that you want us to have to keep? Because we didn't use it last year and we may not use it next year. And then you call a disposal company and you get rid of as much of that stuff as you can. So now what you've got left is what you're using. And now I want you to sit down with your colleagues and come to a conclusion for your institution with your skills, your facilities, and your students. How toxic is too toxic? How flammable is too flammable? How corrosive is too corrosive? How reactive is too reactive? And have a line that you all agree on and have an appeals procedure. So if somebody wants to come along and use something that's above the line, the group has a way of addressing the appeal. And then look at all the experiments that you're doing and the chemicals that you have there and see if any of the ones you're currently using are above the line. And if they are, then think about ways that you can perhaps substitute something that's less hazardous. And if you should discover that it's really nasty stuff like dimethyl mercury, and I'd be surprised if many of you were using dimethyl mercury, where one drop can kill 50, 120 pound, 125 pound people, maybe you just want to get rid of it, but not be told by the state government, the Department of Education, or someone else that you can't have this. We don't want to take all the toys away from the kids.
I agree, and we actually do pretty much everything that you've said, but we do have inspectors that come around, and we don't always have, I try very hard to find out what the latest list is in the state of Maine about, there's both prohibited and then non-suggested and then materials. And sometimes they update them, but they don't tell the teachers that they've changed the list. And it's just frustrating to try to find that list.
Well, it's interesting to, back in 79, the Council of State Science Supervisors published a list. We have it in our notebook, and they say things with greater potential danger than pedagogical use. And it was a recommendation for these things. But I was imagining two guys driving down the highway in a Woody saying, well, what do you think about this? Because they got stearic acid on the list, and stearic acid is generally recognized as safe by the Food and Drug Administration. So where do these things come from? What criteria or criterion are these folks using? I'm glad you shared that list with me, sir. Can you help me understand how these chemicals made it onto this list? What is the criteria that you're using? Oh, you have no idea what the criteria is. You just thought it would be a good idea? Was that you and your buddy, or where does this come from? And Ronald Reagan approach, trust plus verification. And I'll be happy to look if anybody comes at you and says, here's a chemical that you think we shouldn't be using, let me know, and I'll look around and try to figure out if there is some good reason for doing that. And of course, you all are familiar with safety data sheets, and that's a real good starting point.
Thank you. That's a great offer. Who else has a question for Jim?
Doris.
I do, and I'll unmute myself. Hi, Jim, and hello, everybody. I'm Doris Lewis. I'm active in the Northeastern section of the ACS, and I'm chair of the Government Affairs Program. And so, to my surprise, an issue has come up from Lori Trahan's office. Something that I was not aware of at all. Sodium nitrite, you're familiar with as a preservative. If you looked at its MSDS, it's nothing like, for instance, sodium cyanide. And yet there are currently suicide online sources that give specific ways to kill yourself with sodium nitrite. You just take the white powder and just stuff it in your mouth, and it doesn't take too much. And this has never been an issue before. I am concerned that it's hanging around stock rooms. It's nothing you'd pick up, I believe, from the MSDS, but if you go online, it's now a trendy suicide means. So first I want to make people aware of that, and then to get your ideas about this current situation.
I'd like to make sure that our stock rooms are secure. And if you have some chemicals that are, you'd like to have them there, but you recognize they have some particular danger, greater danger associated with them, that you put them in the stockroom, which is kept locked in a separately locked cabinet, and there's clear signage. Only allowed people can go in there. I gave a quiz one time. I asked my students, how many ways can you hurt yourself with a piece of paper? And one student wrote, you can make an airplane and poke somebody's eye out. And another student said you can cut yourself with it. And the third said you can crumple up in a ball and choke on it. And another student said you can set it on fire and burn the place down. And the winner was the one who said you can fail the exam. So nothing has been invented by man that people can't figure out a way to hurt other people with it. And recently, I was just watching one of our TV shows, and the guy who was in the interview room, who was being put away for something, and he had to sign a paper, and he asked the guy to hand him, the guy wanted him to sign the paper, and he said, sure, okay, hand me the pen. And he handed him the pen, and he stabbed the guy in the neck and tried several times and tried to kill him. Don't do that with an LSI pen, please.
This the sodium nitrite until recently was available in pure form on Amazon. That's no longer true. It's now just in the form you can use as a preservative. I believe that is the case because the parents of a young man who killed himself with sodium nitrite from Amazon are now suing Amazon. So that's one way to deal with it. But if you can think of any ways where we can just spread the word that this is a trendy thing, probably trendy paper cuts will be next, but this is more and more the case. Whenever I look online at sodium nitrite suicides, I see more and more examples of it.
There is an organization called NEACT. How many of you are familiar with NEACT? NAOSMM.org. It's the National Association of Science Materials Managers. And wherever you're working, you may have someone who is responsible for lab setup, lab takedown, stock room, that sort of thing. You're the one, Anne Marie? Are you a member? NIOSM?
I am not, but teacher, we don't have anybody besides us teachers doing
Okay.
that.
All right. Well, NIOSM has a annual meeting that LSI talks at and gives courses there. And they have a discussion list, and they've got 500 members talking about things that interest lab managers. And this would be a good place for you to plant a seed about this if you wanted to spread the word. Another would be LSI's free discussion list. We have 500 people who are interested in safety, and you can sign up on our website. You go to the resources page and you scroll down till you get to lab safety-L, and you can sign up right there. And so that's an option, and you can drop out anytime you're not happy with the chat. But that's a place, 2 places.
Thank you, because they're looking at regulating the sources, but I'm just worried about all the high school and college labs where there's stuff on the back shelves, and only the adolescent people who are looking these things up to commit suicide are aware.
Right.
So thank you, Jim. All good ideas.
Yeah. And have you contacted AACT? This is the American Chemical Society's group for teachers, chemistry teachers.
I contacted the safety group.
DCHAS or the council committee?
DCHAS, yeah.
DCHAS, yeah.
The website for NAOSM is in the chat.
Thank you.
Good. NAOSMM.org. Other questions, please?
Yeah.
All right, while you're thinking about a question, let me ask you, what is the difference between autoignition and spontaneous combustion?
Source of the spark?
Well, yes and no, because autoignition does not have either a spark or a flame. So there is no source of the spark under autoignition, only in flash point and flame point. And we'll come back to that, the difference between flash point and flame point in a minute, but let's stick to autoignition and spontaneous combustion. Anyone? Okay, Ann Collins lives in Middletown, Rhode Island, and she's working in her kitchen to refinish a piece of furniture with linseed oil. Anybody done furniture with linseed oil? Yeah. Well, she gets done at 10 o'clock at night and throws the rag in the sink and goes to bed. 3 hours later, her husband gets up, smells smoke, looks down the stairwell, flames are coming up the stairwell, and she suffers permanent tracheal damage, and the home is badly damaged. And they sue the linseed oil manufacturer. And I get to have the pleasure of being the expert witness for the plaintiff in this case. And I'm out buying cans of linseed oil. But it turns out that when linseed oil dries, it's an exothermic reaction. So you take a crumpled rag of linseed oil and you throw it in the trash and go to bed. And 3 hours later, it gets hotter and hotter and the heat can't get out. And finally, it gets so hot that it exceeds the auto ignition temperature and bursts into flames spontaneously. There is no external source of heat. The auto ignition temperature is the temperature at which a combustible mixture of fuel and air will ignite without a spark or a flame being present. So carbon disulfide, which is a wonderful equal opportunity male-female reproductive toxin, and it has an auto-ignition temperature of 95 degrees centigrade. So a hot steam pipe or an incandescent light bulb could be hot enough to ignite it. But that's an external source of heat versus generating your own heat. So the temperature is the same for both, but in the case of spontaneous combustion, the heat has to come from within.
Yeah, we had a house in town that burned down for very similar kind of situation about 20 years ago.
Yeah, the label on the linseed oil was terrible. It said, "Do not eat." And then you turned it over on the other side and it said, photochemically reactive. I don't know about that, because this can happen in the dark. Thank you. Other questions? Okay, who knows what an acronym is? What would be an example of a chemistry acronym?
NEACT.
Yeah, NEACT. And what is the difference between an acronym and an initialism? Who's familiar with initialisms? Aha, okay. We don't refer to the Federal Bureau of Investigation as FIBI. We call it the FBI. And we don't call the American Conference of Industrial Hygienists, ACGIH, the American Conference of Governmental Industrial Hygienists, or something like that. we don't call it agric, right? We spell it out. And so any abbreviation of words that you spell out, like the Central Intelligence Agency is not, it's the CIA, it's not CIA, is called an initialism. Why don't you start a lab safety bulletin board on which you're going to put six things. And one of them will be safety vocabulary. And on one side of the card, you write the word, and on the other side of the card, you write the definition, and you pin it up on the bulletin board for everybody to see, faculty, students, everybody. And the chairman of the department has to go first to say it's okay that you learned a new word that you didn't know before. When I went to the Middle East one time, I had an induction, they call it. That's the orientation. They call it an induction. And my inductor was telling me about wearing a balaclava. And I had no idea what a balaclava was. But then I realized when he showed me the picture, it looks more or less like a terrorist mask that you pull over your head. In fact, I have one in a box over there that's white for protecting your head when you're working in a lab and you don't want to get stuff in your hair. So, yeah, put up those new words.
We have
one
a
thing.
question, Jim.
Good.
Sorry to interrupt. So, Anne-Marie?
Hi. I'm still relatively new. This is my 4th year teaching high school. I used to work in academic research labs. So where it was like all those safety protocols and everything were already set in stone. We had regular inspections. There were people whose jobs it was to take care of the waste and all that kind of thing. And so, and then with COVID hitting right in the middle of my experience as a teacher, you know, the lab situation here has been, spotty, and just really this is the first year that we've been back full force. And I have a lot of hazardous waste that I've generated, and this will be my first time requesting a pickup. And so I'm just curious. I know, like, I have to follow the rules from my local, whatever they need me to do, whatever forms they need me to fill out. But I'm curious from both for Jim and from other folks who have more experience, like, what are some of the do's, don'ts, bad stories, best practices that you've come across as far as dealing with hazardous waste in a high school lab?
Would anybody like to lead off and make some suggestions?
What is your storage situation? I've worked in schools where I had a miserable closet, and I'm now luckily in a place that we got to design and actually has proper storage. So that's probably my first question, because you got to go with what the facilities are that you have. And my second would be, where is it relative to your students?
Right. So we have a separate stockroom area. It's between 2 of the chemistry classrooms. So I have a direct door to it, but it stays locked, like we were talking about before. The students are not allowed in. Even my student aides are not allowed in, et cetera. And so that's where our chemicals are stored when they're not in current use. And that's also where we keep waste. So I have a bin of with different types of waste sort of separated out within the bin that's separate from all of where we store the other chemicals, except for flammables, of course, which are still stored in the flammables cabinet. So we have, we also have like decades worth of chemicals that probably we need to call a disposal company and just get rid of a whole lot of things. Yeah, no, I really like your idea of the dots, and definitely going to implement something like that. But so we have a space to put the waste as it accumulates, but I haven't, so we've accumulated some. So I have, some lead iodide, and I've got some old chromium waste and things that we've pulled out of the storage cabinets and said, yeah, we're not ever going to use this again and we need to get it picked up. There's way more of that. But so right now the accumulation is relatively small, but like as I continue to teach IB, I'm hoping to do more organic experiments and things. And so like, you know, I have an organic waste jug, but like, I don't know. Yeah. So I'm just curious about, like I said, best practices and biggest problems that you've seen.
Anne Marie,
Okay,
can I say what we had to do in our lab?
please.
So I'm in Atlanta, Georgia. I'm teaching IB chemistry for the 3rd year. I started, of course, during COVID, and it's when I got here, there was stuff from 70s and 80s. I had things rusted, no name, no idea what it was. So much stuff with no idea what it was. And our county has a contracted company, and I was trying to go through it. It took forever because they wanted a list. They wanted everything and how many mils, how many grams, listed all. And I finally convinced them that I can't do that. It's impossible. I don't even know what the stuff is. Finally, the county agreed to pay for them to come out and just evaluate everything. They hauled off, 50-gallon drums. Of course, there was a lot of packaging and stuff in there, but just drums and drums of stuff. And I mean, I felt like I couldn't even go in there to work. There was a nitric acid bottle in the acid cabinet that had completely corroded and it was a mess. So anyway, that is my contribution to you, is maybe you can convince somebody that somebody else needs to make this decision. And I do have a question, if we round about and come back to this, how are you deciding what goes together for waste for storage?
That's a great question. And it's mostly been using the Flynn guide for what gets stored together in general. We do have our cabinets organized by the Flynn system. And so I've been kind of trying to do the same thing with the waste. And, put nitrates together and put, or things that can't go down the drain. Obviously the things that are going down the drain are going down the drain, but, trying to follow the system in the Flynn guide. That's what we've mostly been doing.
Okay. Another question along that line of the nitric acid, the Flynn guide said, I think it's Flynn that says it should have an absolute separate,
we have a cabinet within our acid cabinet.
That's what I'm wondering. And I wanted to ask Jim, is that necessary to buy? I've seen 2 different things. Buy this individual cabinet that goes in your big acid cabinet. And I've seen just have a separate open plastic container that it sits in.
Probably sometimes it could be a big one that looks like this. A bottle carrier. Yeah. Safety is a judgment about the acceptability of risk. Some of you may have any of you ever enjoyed going skydiving? Anybody feel that's too dangerous? You don't care how many parachutes they give you, that's off the chart. What about riding a motorcycle? Anybody ever rode a motorcycle or been a passenger on a motorcycle? Okay. Anybody feel that's too dangerous?
He's a very handsome guy. What can I say?
Yes. Okay. So did you see the movies, Laura Croft and the Tomb Raiders? Who was the actress who starred in there?
Angelina Jolie.
Yes, Angelina Jolie. And she did all of her own stunts, and then she took a year off to make something else. What did she make?
Did she do Mr. and Mrs. Smith? Oh, she made babies?
She made a baby. And then she came back and she made the spy spoof movie, Salt. Anybody see Salt? Yeah. Well, in the middle of that, making that movie and doing the stunts, she said, I can't do these stunts. They're too dangerous. And the stunts really weren't more dangerous, but the equilibrium had shifted. Now, because there was a child, her thinking about the risk involved, her perception of the risk changed. And so this is in part what we need to apply here in thinking about the relative risk. And when it comes to whether you want to pour things together or not, you need to understand incompatibility. And there are lots of good incompatibility charts online. And as an aside, I would point out that many of you mentioned the Flynn system and their 28 methods. That was developed originally by the Chemical Manufacturers Association. And when the EPA came out with the Resource Conservation Act, the Chemical Manufacturers Association stopped publishing this guide. And Flynn took it without attribution and made it theirs. So some of us call that plagiarism. I don't know what we'll call it, but it would have been nice if they'd given the Chemical Manufacturers Association some credit for that. There is good advice about disposal of waste, but it also says we're not going to join you in jail if you get arrested for following any of these. So be careful in whether you want to do any of those things. And any suggestion to evaporate stuff in the hood, don't do it. You can face thousands of dollars of fines as a result of that. Back to Anne Marie's original question. You've got all this stuff there, and some of it you don't know what it is, and you don't want to have orphans. Orphans can be very expensive, a couple of $1,000 per bottle to figure out what they are. So number one, don't let the labels fall off your containers. Every year, go around with a tape packing gun with wide plastic tape, and any bottle where the label is starting to peel off a little, do a bunch of 360s and encapsulate the label so it isn't ever going to fall off. And if you can get the company that's taking your stuff away to help with the identification, there may be other ways you can identify some of these wastes. It's also good to ask them, what degree of segregation should we follow that gets us the lowest price? And you don't want to mix, for example, a halogenated organic waste with a non-halogenated organic waste, because that first group are much more expensive to dispose of than the other group. Pam, did you have a question? Were you? No, okay. Let's see, what else?
I was just nodding about the halogenated. Yes, that I have been separating that.
Yeah, good. Okay. And now your waste disposal room needs to meet certain criteria. You need to be able to contain things that are going to spill. And so having secondary containers around these supplier bottles and workplace bottles, you need to do that and have it be with a compatible material that's not going to dissolve. It's good to store oxidizing acids, nitric and perchloric, separate from the other acids, and it might just be in a separate little container. Anuja, did you have your hand up for a question?
No.
Okay, I saw the hand up there and I thought, well, okay. Let's see, what else can I tell you? The bottles need to be labeled with the word hazardous waste, the name of the material that's in there, or materials, and the hazard that they pose. And if it's not, it could cost you $5,000 a bottle. And the label has to face forward. so that you can see it.
Mhm.
If it's facing the other way, big bucks. So these are some things that you can do that would make it better. On our website, labsafety.org, in the resources in the shop, there are posters, and there are posters that are free. And one of them, I believe, is the Golden Rules of Chemical Waste Disposal. So you can get a poster that talks about some of the precautions to take doing this. And the room should be well ventilated. And if your bottles, right, and if the room is in between the two labs, right? Does it have its own ventilation?
Theoretically it does, but we have determined this year, after a bottle of isoamyl alcohol broke and spilled inside a flammable cabinet, that it is not actually well ventilated, because that room was
Okay.
stinky for a long time. So it has its own vent, but it doesn't have its own hood. Or
But the vent, is it going out of the building, or is it just sharing it with everybody else in the building?
I don't actually know the answer to that.
On your action idea list for today, please write down, find out where the air goes. You want it out of the building. And you want to have, 4 to 10 room, at least 6 room air changes per hour. Now, if the room that you're in has a wall that's adjacent to a fume hood, steal some of the exhaust from your fume hood. Run a pipe. No. Why not?
The fume hood's on the other side of my classroom from the fume hoods in our classrooms are both opposite the wall that has that we share with the storage room.
You have a drop ceiling?
I guess. This is where I'm really ignorant about everything.
Okay, that looks like tile panels above you.
Yeah.
So if you can, maybe you can run a pipe along there, a 6-inch pipe, through the wall into that room, and with the hood on, you draw air out of that room, and it goes up the exhaust of the fume hood. But the fume hood needs to generally stay on then most of the time.
Yeah, it's really loud.
Oh, that's bad.
Yeah.
How about the other room? Is it also loud?
It's all the same. It's old and loud. Yeah.
Okay. Speaking of your fume hoods, who checks to make sure they're working properly? You do.
I do the ChemWape test, but beyond that, no.
Okay. Well, I have one client that had 5 sash cables break in 3 years. There have been broken fingers, broken hands, broken wrists, broken arms when the sash cables break. And so Lab Conco, for example, says, check the sash cables on your fume hood every 2 years. I say 2 to 3 years. I'm a little more cavalier about this, but the last one that broke, he had his head in the hood, and he heard the bong, and he pulled back, and he took the hit in the shoulder. So it's a guillotine. You've got guillotines in your labs, and you want to make sure that the sash cables are okay. So I saw a hand go up before. Somebody had a question, I think.
Might be me. I was thinking, Jim, about your Angelina Jolie thoughts. And when people are talking about going into a lab and finding all the stuff, with the labels falling off and all of that, I've been there and done that, and I'm no longer in that situation, and I'm not dealing with young people anymore. It's occurring to me that what's different is not the chemicals that are there, but I'm reading about a suicide epidemic, or at least a depression epidemic among young people, which might be a burden to chemistry teachers that you've never thought about before. Am I correct there, or is that overblown?
I'm not aware of any statistics about this. I have had maybe one or two stories, if I think back, about this sort of thing. And there was one case where a student took a bottle of potassium cyanide with another student and put it in a Coke and dared another student to drink it, and he died. And there was a court case involving that. The student claimed that he didn't understand the word on the label, which said lethal. So I said, well, he's pulling our leg. So I had an organic chemistry class with 6 or 7 students in it. And I wrote the word lethal on the board. And I said, write down the meaning of this word. And nobody got it exactly right. And these were sophomores and juniors in college. And I thought, look at that. So maybe we need to teach more. It has to start in the schools where people understand. And that's where the vocabulary is important. How many of you have a copy of the book, Prudent Practices in the Laboratory? How many of you would like a copy for free? This is the publication that, do I have my copy here? Yeah, I have my free copy in the bookcase over there. It's published by National Academy Press, nap.edu, Prudent Practices in the Laboratory, 2011 is the 3rd edition, and it is the basis going back to the 90s for the OSHA Lab standard. So if you would like a free copy, type into Google, Prudent Practices in the Laboratory, 2011, find the link that goes to nap.edu, and you'll see you can buy it there for $100. Or you can move over a little bit and hit the button that says free PDF and download the free PDF. If you want to buy it, order it from LSI. It's less expensive from us. But if you want the free one, and I would encourage you to do that, then good. You can get your own. I became jealous of Oprah a few years ago because she had a book club and I didn't have a book club. I wanted to have my own book club. So I started a Prudent Practices book club. And it was a discussion. And every week, 2 weeks, we met and discussed a chapter. And then we kept going. We recorded all of this. We went through it twice. We recorded all of these discussions. And, somebody posted in the chat. Good. The Prudent Practices. Okay. And we recorded them, and you can go to our website and you can see them and listen to them for free. You go to the resources section and you scroll down to the monk sitting there at the round table for the discussion, and you'll see all the chapters of the book, and you can do that. Start a book club of your own. Get everybody to do it. If you have a science club, you have science students that want to graduate and go on in chemistry, got a chemistry club, have them all get a copy of Prudent Practices and start reading it and having discussions about it every week or two. They have to learn more from you. Pam, Auburn, did you have a hand up there? You had a question?
I did, but I wanted to go back to what Doris was talking about in terms of suicide risk. So I actually worked in a lab where we had a graduate student take sodium cyanide and kill his father. So I've seen this. I think it's always a concern. I don't think it's anything new. And you need to make sure that your chemical storage is locked and that students don't have access.
Yeah,
I would agree. Is there more depression and suicide than before? Yes. But if your storage is really locked up, then they're going to go elsewhere. And that sounds harsh, but you just want to deny them the opportunity, because frankly, in our area, they use a lot of other means, because they're easier to get to, right? They're not in our chemical storage for here or the several research companies that are nearby, because they're too well protected. So they're not going to go there.
Yeah, and I
There
mean,
was,
it's not just the chemicals. We actually fired a teacher who was taking glassware because they thought they were going to set up a meth lab. So we had our own Breaking Bad person.
we've had students take stuff and put it in their locker in the hallway and have it explode. Fortunately, nobody was in the hallway when the explosion occurred. There was a queen about in the 1500s who wanted to kill somebody, and she soaked a book with cyanide, I think, so that when he turned the pages, the victim would be getting this dose of cyanide. Unfortunately, her son got the book, and it killed him or almost killed him. I'm not sure. I don't remember. It was a movie about this and this queen. Yeah, so it's not that uncommon. Other concerns? Yes. Jerusha?
I find the MSDS sheets very frustrating because
Okay.
I feel that I feel like it's very hard for me to make a good analysis on the actual safety of something by reading them. So for
Okay.
example, I'm trying to think about something. There was some chemical that I didn't think was going to be problematic, but I wasn't 100% sure. So I looked through the MSDS sheet, and the wording of it made me a little bit concerned, but it wasn't like, lethal or anything like that. And so then I thought, well, let me see what it says for sodium chloride. And sodium chloride had exactly the same wording. And then I looked up, something that I knew was a little bit more concerning. And basically, I feel like a lot of these chemicals, these chemical companies have to cover their ass. So they list every possible problem that these things can have. So now when I read it, I don't know what really is problematic and what isn't. I don't know. Has anybody else had that feeling? I'm pulling up the data sheet right now.
Yeah.
So here
Well,
it says, so for sodium chloride, caution, may cause eye, skin, and respiratory tract irritation. All right. So I kind of know that sodium chloride's not particularly harmful. I don't think I have to be really careful about making sure that my kids are wearing masks and doing it in the hood. But then if I pick out something that might actually have some respiration and it uses those same words, how do I know?
Under the globally harmonized system, GHS, we now refer to these as safety data sheets. MSDS is a word that was used in the past, and we want our students to hear us talking about safety data sheets. And we need to become familiar with all 16 sections of the standardized safety data sheet. And in response to your question, I would like you to pay particular attention to section 8, which is the
exposure controls.
Yeah, and that talks about the permissible exposure limits, the PELs from OSHA, the TLVs from ACGIH, and the RELs, the recommended exposure limits from NIOSH. And sometimes you'll see that NIOSH is more, the others are more conservative than OSHA, and OSHA will enforce generally, with some exception, the lowest level if they don't have one of their own for that particular.
So I'm
And then
looking
I'd
at,
like you to all,
well, I'm looking up it right now and it says for sodium chloride, wear appropriate protective gloves to prevent skin exposure.
what is the PEL in section 8?
So it says eyewear, skin and body protection, wear appropriate protective gloves and
Are you
clothing.
looking at an MSDS?
No, I'm looking at the Flint Scientific Safety Data Sheet.
Okay, well,
And
what
then,
I would
and then it
suggest
says
that you,
respiratory protection, approved respirator if exposure limits are exceeded.
how many sections are there in that sheet?
There's 16.
Okay. Section 8 should include the permissible exposure limits. And if it doesn't, it's not a good safety data sheet. So you want to look at Sigma Aldrich and you want to look at Fisher Scientific and
This
you
is
want
the
to
Fisher one.
Yeah.
Yeah, this is the Fisher one. Yeah, so, okay,
So
well, that's helpful.
And I want you to look at section 11, which is the toxicology section. And
Mhm.
that's where you'll see the LD50 and the LC50, which is the lethal dose that kills half the population. We have a coffee maker in our conference room, and it says next to it is a sugar bowl, and on the sugar bowl it says sugar, and underneath we wrote LD50, 25,000 milligrams per kilogram of body weight. And that's the amount that will kill half the rats. So a 1 spoonful, 12 grams of sugar on a spoon to a 1 pound rat is enough to kill half the rats. Whereas on the other hand, methanol is about 5,500 milligrams per kilogram. So it's 5 times more toxic. And cyanide is 4 milligrams. So it's about 1,500 times more toxic. And this gives you a relative thing. Now, here's the activity for all of you. The next item on your lab safety bulletin board is going to be the safety data sheet of the month. Never mind the sodium chloride. Let's write down give out a blank sheet of paper at your next staff meeting and ask everybody to write down what are the 10 most dangerous chemicals we use in our work here. And then you collect all these lists. How many members are there in your department, Jerusha?
20.
20. Then you're going to have 200 suggestions, and I want you to rank order them in an Excel spreadsheet, and you're going to have your David Letterman top however many list, right? Probably 50 or 60 chemicals, and you're going to put the most common ones at the top. If you do this right on your Excel spreadsheet, it'll tell you which ones is the best. So, most dangerous. And then pull off the top the conference all-stars, the ones that 80, 90% of your colleagues agreed these are the nastiest ones. And give one to each of your 20 colleagues and say to them, from now on at our staff meeting, we're going to have a safety data sheet of the month. And when your turn comes, you're going to read this very carefully, and you're going to report to all of us on the hazards and precautions. And you're going to learn about the difference between the ratings in NFPA, which are 43210, and in GHS, which is 1, 2, 3, 4, 5. Interesting. I said to my niece one time, how are you doing in school? And she said, I've got a 1.5 average. And I said, do you think you should study harder? And she said, no, that's an A minus. And she goes to school in Germany, where an A is a 1, a B is a 2, a C is a 3, a D is a 4. So you got to know what system you're dealing with. And after they make this presentation to your department, pin it up on your lab safety bulletin board as the SDS of the month. Over the next 20 months that you meet, you're going to review the hazards for the most dangerous ones. And if somebody thinks it's fun to take the ones at the bottom of the list that, you know, well, fine, but get the consensus and really look at these SDSs. And if any of you ever have a chemical that you would like to discuss its hazards and the information that's available about it, send me an email, give me a call, and we'll look at it together. And we'll see what conclusion we can come to. If you want to go down that path with sodium chloride, I'll do it with you. And we'll see what conclusion we come to. Instead of looking up at this point the SDS, try going in and saying sodium chloride permissible exposure limit or sodium chloride LD50 and see what numbers you get. And then you can compare this relative to other things that you're using. And yes, if you eat too much sodium chloride, it's not good for you. And that's also true about sugar.
Right. It was more just not like, I know the sodium chloride, but I don't know this other chemical. And I just didn't know how worried I should be, whether I should use it.
Then you need to compare the PELs, the RELs, and the LD50s and LC50s.
So
and their
PELs, what are the same again? PEL?
permissible exposure limit.
Yep.
And by the way, where is your school located? What state?
Connecticut.
Okay. Connecticut is a state plan state. Do you all know what a state plan state is, what that means? It means that you are an OSHA state plan state, and that your state has submitted a plan to OSHA that was as strict or stricter than the federal plan. And they are now enforcing this. In Connecticut and in New York, they only do this for the public sector, and they've left the private sector to federal OSHA. But in your state, it's a state agency that does this, that enforces this. And you need to have a written chemical hygiene plan, and you need to have a chemical hygiene officer.
We have both.
Good. And you need to provide training and information to all of your teachers about PELs, time-weighted averages, short-term exposure limits, ceiling limits, and OSHA requires this at the time of employment. Whenever the nature of the hazards change, a new chemical comes in, and if your school isn't doing it, then they are violating the state law.
Our safety guy, great guy, but he and his students eat in the classroom all the time. So I don't have.
Well, this is not a good sign, and depends how much waves you want to make and how many friends you want to have, I guess. But you can call OSHA and invite them to come in for a no fines, no penalties inspection. Or you can ask LSI to do that, and we do it virtually or in person.
Thank you.
Other questions,
Jim,
please.
That is a wonderful
time's
offer.
up.
Yeah, I do want to honor people at this busy time of year. I think your offer at the end, it sort of embodies the spirit with which you joined us, which is so warm and welcoming and inviting and non-judgmental and problem-solving oriented. And just thank you. Thank you, thank you, thank you, thank you.
My pleasure. If you want to have another round sometime, happy to come back for another helping.
I'll definitely put you on the rotation for next year. And the exec board is meeting this Sunday, and we'll talk about how to get your links onto our website. That's on my agenda anyway.
Okay.
So it's happening.
And-
It's happening. I've talked to your tech guru.
Connor Michael,
Yes, yes.
good guy. He's in New Mexico. So if anybody wants to stay on for a while with other questions, I'm happy to stick around if anybody wants to go further.
Jim,
Yes.
I'll ask you about, I've seen where ammonium nitrate should be stored not with other nitrates, but completely separate. Is that a necessary thing, or how close? What's your idea on that?
It's a very strong oxidizer, and it should be stored with other oxidizers and things that it's not going to react with. There is a book by Bretherick called The Handbook of Reactive Chemicals. That's thousands of pages of what goes boom with what. You can look up ammonium nitrate and not what you want to have it around, certainly not organic chemicals.
Mhm.
And the National Fire Protection Association has a guide that has about 100 pages of chemical incompatibilities.
Okay. Thank you.
And that's what Terry Nichols and Timothy McVeigh used to blow up the Murrah, Oklahoma federal building and take out a daycare center.
Yeah.
Ammonium nitrate and diesel fuel.
Yep.
Bad. Write down these letters on a piece of paper, please, in front of you. H, I, J, K, L, M, N, O. Everybody got it? H, I, J, K, L, M, N, O. If you've never heard this before, what is that chemical formula? Anne Marie? What do you know? What are you looking at? What do you see there?
The middle of the alphabet.
From what to what?
From H to O. H2O.
H2O.
Uh-huh. I like it. I like it, Jim.
That's my favorite.
Yes, nice. Hey, Elizabeth, I threw my email to you in the chat. I would love to trade IB Chem stories at some point.
Yes, yes. Thank you so much. Do you teach IB chemistry?
I do.
Ooh, I need some collaboration bad. I've been in
Don't we
a boat.
all?
I've been in a boat by myself for 3 years. I really need some collaboration. Thank you so much.
Definitely.
Would IB chemistry be something that you would be interested in having a ChemChat around?
Ooh, that's a great idea.
Yeah.
Because I'm already starting to pick up. We've got June. I'm off for July, and then we start up again in August, but I can definitely put that in. And so since you two ladies are here, sorry, Jim, I'm gonna ask them this. Pick a month. Is this something you like to think about in the summer, in the fall?